Hello, and today I'm going to be talking about my science fair project, an environmental stewardship project on cleaning the creek. So, I would like to say that rivers around the world have been constantly polluted from human-caused or anthropogenic effects, either intentionally or unintentionally. As the pollution and trash make their way towards the ocean, they join up with more trash from other rivers, of increasing in the concentration of pollution right before it reaches the ocean. One way to reduce this from reducing the pollution in rivers and oceans is by cleaning the trash in the rivers. Cleaning the trash in rivers would also take away a lot of the harmful chemicals found in plastics like DDT, PHSs, and PCBs, and some other pesticides. And another problem with these chemicals is that as each as an as each animal along the food chain eats other animals, not infected, but have these chemicals in them, the concentration of these chemicals increase in the higher in the food chain you go until it reaches the apex predator, which can also sometimes be humans. And another alarming thing about chemicals or toxins in the water is that PCB concentrations in microplastics in the ocean have been found to be a millionfold greater than the concentration of PCBs in the surrounding water. And another alarming fact about toxins in plastics is that most of them have remained largely unidentified, posing health and safety risks to humans and aquatic organisms. So what I'm thinking is that trash, which is largely plastic, may contain toxins and other chemicals that may impact the quality of water. So what I want to figure out is, will cleaning up the trash along Haney's Creek improve the water quality and reduce the amount of trash in the creek? So Haney's Creek will be selected for study due to its proximity to my house and the ease of getting there. So the two sections of the creek which I'll be cleaning up will be along the Kensington Park Pool on the top and Hurd Elementary at the bottom, which these red lines being the sections in which I'll go along the creek and clean it up. Though the sections will start and end where the tree lines start, and we'll go through the fields and where the sections are, like the field here and the field where my cursor is for Hurd Elementary that's obscured by trees. I'll also be wearing gloves while cleaning the trash for safety reasons, along with having a trash bag to put the trash in and a rake to pick up the dirty objects that I don't think I should pick up with my hands. I will then weigh, record, and discard the trash that I've collected. I will also go down the creek on Saturdays where I'll only clean up one section on that Saturday, and then the next week I'll clean the other section. So for each section, I'll clean it once every 2 weeks. I'll also collect water samples every Monday, Wednesday, and Friday and test them for salinity, total dissolved solids, electrical conductivity, total hardness, free chlorine, iron, copper, lead, nitrite, potassium peroxymonosulfate, total chlorine, fluoride, cyanuric acid, ammonia chloride, bromine, total alkalinity, carbonate, and pH. I'll also use a color wheel a color chart to identify the concentrations of all of these water quality variables except for total dissolved solids, electrical conductivity, and salinity, where I'll match the colors from the test strips to those of the color chart to identify concentrations. And if I find a color on the test strip that doesn't match with matches with both colors, I'll choose a concentration in between what those two colors represents. So I'll start the experiment on September 19th, 2020 and end January 25th, 2021. I'll record the data in 2 Google spreadsheets, one for trash collection and one for water quality results, where the column of the trash collection spreadsheet will be the section of the creek in which I clean the trash, and the rows will be the number of the week number in which I collected trash, starting from week 1 at the top, going down to week 19 at the bottom. for the water quality results, the columns will be for each of the water quality variables, and the rows in which will be where the dates in which I collected, starting at the top down. I'll also use line graphs to like visualize the progression of water quality of the water quality variables and amount of trash collected over time, where the x-axis for trash collection will be the week number from like 1 on the left to 19 on the right, and for water quality, the x-axis will also be time, in which the date from the dates in which I collected and assessed the water quality, starting on the left and going to the right. For the trash collection, the y-axis will be the weight for the trash collected, and the y-axis for the water quality data will be the concentration of the the variables of water quality, the pH or salinity. And so what I found is that a noticeably decrease in the amount of trash collected per cleanup, as in the first half of the experiment, I generally found I had instances where I collected trash that weighed 2 to 4.2 kilograms, minus the weight of the tire, wheels, and wagon that I found. But in the other half of the experiment, from weeks 9 to 19, the amount of trash collected never surpassed a weight of 1 kilogram, while the water quality trust showed very little or any noticeable change over time. I also found 2 tires at Hurd Elementary, like car tires, where one of them weighed 15.876 kilograms and the other weighed 10.433 kilograms. I also found a wagon with 3 wheels in the Kensington Park pool on November 14th, and for the 2 tires I found them on the September 26, 2020. And where with the wagon I found it had a weight of 21.682 kilograms. The other wheel was found the week prior along the section at Hurd Elementary and was weighed with the other trash. So for the graphs of the trash collected over time, the one on the left included the weights of the wagon and tires, and on the right included the weights without the wagons or tires. So you can see that over time, the amount of trash collected decreased, most notably on both ones, in which you had instances in which a large amount of trash was collected at the start of the experiment, but noticeably decreased over time. And over here on this slide and this slide, I included the times in which I assessed the water quality of the water, and I was only able to collect to do water quality assessments for 3 days for reasons I'll explain later. But if you look, the water quality didn't change significantly, and in regards to the color chart, it only changed the color strips only changed between 1 to 2 of the concentration things. It's 0.2 to 0.4 on the concentration strips. And in conclusion, I found that due to the amount of time to find and ship these reliable water quality tests, I was only able to perform 3 water quality assessments, which with those 3, I wasn't able to determine anything significant about how the quality of water changed over time. But I did find that the cleaning efforts of over time worked in reducing the amount of trash I had to go clean up. And to better assess if trash improved water quality and reduced the amount of trash collected each next cleanup, I will have to do more cleanups and extend the experiment. And this is only snapshot. I feel like my snapshot of the experiment, since I feel like it's incomplete and more experimentation has to be done. So these are the sources in which I pulled information from about plastic pollution and toxins in water. And this is the end of my presentation. I hope you liked it, and I hope you learned something about environmental stewardship and pollution in rivers, and hopefully find a need to clean them up. But this is where I'll leave it. Have a good day, and stay alive out there.